Good afternoon, guys, or good morning, wherever you're coming in from. I'm here to explain question one of the pretty difficult, I'm with Sai, my good friend Luca. Question
and
one
Chris.
of the pretty, Chris behind the camera, sorry guys. Question one of the pretty difficult calculus, AB, FRQ. First question, we begin with a chart here. If you look down here, I've pretty beautifully recreated it. About a coffee cup and minutes and degrees Celsius. And question A asks us to approximate C prime of 5 using the average rate of change of C over the interval 3 is less than or equal to T, which is less than or equal to 7. So essentially between 3 and 7, which are, as you see, these 2 points here. So we're using these 2 middle points of this table. We're trying to find an approximation of what C prime of 5 is. In order to do that, we're going to use the slope equation. Y2 minus Y1 over X2 minus X1. We're going to essentially just plug in, this will be Y2, this will be 0.2 in our example and 0.1. I'm just going to plug those in. So we'll end up with 69 minus 85 over 7 minus 3. And then you can do some fun math with that. And you end up with negative 4 degrees Celsius. Well, that's E, Celsius. And
Per minute.
Per minute.
Per minute.
Good add from Sai.
Thanks, Sai.
Thanks, Sai. Shout out, Sai. So that's what we end up with for question 1A. Thanks for being here, guys. See you in the next one.
You paused it, right?
Okay, so this is our next question for the FRQ that we're going to go over today. So it asks us to use left Riemann sum with 3 subintervals to approximate the interval from 0 to 12. So then we have to interpret the meaning of 1 over 12 and then the interval from before. So to do this, we're going to first do the left Riemann sum. Thanks for the angle, Travis. We're going to... So the first step is to use left Riemann sum. So what's that? 3 minus 0 is 3 times 100 is 100.
Wait, why are you using 100 and not 85?
Because that's the first one, and it's left Riemann sum.
Side.
All right. Then what is that? Is it plus? We plus, yeah. So then we do 7 minus 3, 4 times 85. Like that's where the 85 comes in, Travis. Like what you were asking before.
Thanks.
And
Thanks.
12
Teach.
minus 7, 5 times 69. And then that would be the using the left Riemann sum. And that's what that would be equal to. Next, you have to interpret the meaning of 1/12 of that, which is essentially the same thing as the average of how much degrees change per minute from the period 0 to 12. So it's essentially, it's saying how much it would change per minute in Celsius. Shout out Big X.
Alright, so for this question, we're here to approximate the temperature of C at time C equals 20. And we're given both a model of C prime of T after times T equals 12. And we're also given the temperature at times T equals 12, which is 55 degrees. So without further ado, to get on to the question, we start C of 20 equals, we're going to start with the time we're given at the start. So C of 12, which is going to turn out to be 55, minus what we have here in this function, which is going to turn out to be 20, 12, and then we're going to end up with C prime of T dt. Sorry for the squeeze-in-ness of this, but this is going to turn out to be C prime of 12 is 55, as we covered. And then if we take this, which we have already done in advance, and plug this into a calculator, that function is going to turn out to be negative 14.670, and once you do the math, you have your answer. Thank you very much. All right, so for this last question, we have The question reads, for the model in part C, it can be shown that C double prime of T, which is given here, and then considering that for 12T to 20, determine whether the temperature of the coffee is changing at a decreasing rate or at an increasing rate. So considering that C double prime of T is positive, if you remember, we can do several ways to determine that. For the given time frame, the temperature of the coffee has to be changing at an increasing rate of change. Again, because C double prime is positive. Since C double prime of T is greater than 0, C prime of T, which represents the rate of change of the coffee, must be increasing.